guest or visitor.
Okay. No password, just open. Okay. That's how we tell people that are insecure. Like, oh yeah, that random Wi-Fi. We're gonna do that.
Yeah. We're gonna have all the organizers come up and say like, "Hi, this is us," and then leave.
Okay.
We want to do that before or after we talk.
Why don't I do it right here? Why don't I just say like, say welcome, and then have everybody come up?
All right.
All right. It is 9 o'clock.
Okay, let me do it.
Ready? Good morning, everybody. Are we pumped? Let's get some energy going. This is awesome. Thank you for coming out today. I'm going to have all the organizers come on stage with me here. We'll do a quick intro. So if you guys don't know, and sorry, I'm from Cleveland. We say you guys as a gender neutral, so apologize. So it takes about 6 months to plan one of these. So weekly meetings, a lot of work go into it. So these are the folks that make it happen. So I'm Kathy Clark. I run the AWS Cleveland group. Nice to meet you all.
Hi, I'm Brock. I'm here in Columbus.
Nathan out of Indianapolis.
I'm Harper. I run the AWS Michigan user group.
I'm Lena, Columbus.
I'm Dave, Milwaukee.
Thank you guys. Appreciate it.
Oh, one more.
Oh, we got some more.
Two more.
Angela's organizing.
He's
working.
doing organizing all the time. All right, Angela, who are you?
I'm
someone taking a
Angela
picture?
Mandato, the
Yes.
music group leader here in Columbus, Ohio.
And Margaret.
And Margaret?
Hi. I organize the Chicago user group.
All right. And I didn't notice this until just now. We've been working together for 6 months. We are split gender-wise, which is amazing. So thank you guys. All right, want to also give a big shout out to our sponsors. Our gold sponsors are AWS, woo, reason they're here, and Manifest Solutions. And our bronze support comes from Veeam, Rhythmic Technologies, and Rigo Consulting. So thank you very much for making this happen today. We've got a packed agenda. One thing I do want to note, get out your phone, please, because this is very important. If you did not scan the barcode on the parking, please do it now. We definitely want you to come out to a vehicle. So the directions for doing that, give me just a moment. You'll go to parking.com and select the zone and enter 93732. I'll say it one more time. So it's parking.com. In the zone, you're going to enter 93732 and enter your license plate information. So thank you very much. I'll probably give you one more reminder because, yeah, no one likes getting towed. All right. So we opted today to cram as many sessions in as possible, so we don't have any scheduled breaks. So please kind of self-regulate. If you need a moment, step out into the hallway. Just try to be mindful, obviously, of talking too loud in the hallway to not interrupt the sessions. The day is also supposed to be interactive, so hope you're going to take advantage of the lunch and the network times. That's really what this is all about, is learning, but also community, which makes it one of my favorite days of the year. So we've asked the presenters to allow Q&A time at the end rather than go the full 30. So, write those questions down for the end and keep this interactive. There are 2 talks to please note that cannot be recorded or photographed. And that's Jeff's talk on how does RAG really work at 2:30 in track 3, and Tom's talk behind the scenes of Amazon's supply chain and logistics at 3:30 track 2. I'm sure the speakers will remind you again, but please, it's very important. We appreciate them sharing this information with us that isn't meant to be public. And maybe their sessions are top secret, maybe they're not, maybe it's a marketing ploy. We won't know till you go. On the food area, we've got coffee, tree. We have tree. Coffee, tea, and soda all day. Lunch is going to be from 12 to 1. And then at 4:30, we've got a happy hour with some light snacks and beer, wine, and non-alcoholic. I've had too much coffee, not enough coffee, it's hard to tell, and non-alcoholic options. So that is all the housekeeping. So for one more time, parking.com, zone 93732. All right, without further ado, we are so excited about our keynote. If you don't follow him, please do. He's streaming like 3 days a week and is just a fun human too. So to present, why does everyone keep talking about generative AI? It's Darko Mesaroš.
Why does everybody keep talking about generative AI? This is a guy who's about to talk about generative AI. Give me a second. I was supposed to join a Zoom meeting. Is this not a thing anymore? Nope. Okay. Ignore me. Leave webinar. This is not a webinar. Thank you. PowerPoint. It's been such a long time since I did PowerPoint. So, hello everybody. Welcome to the show, to the AWS Columbus Community Day. It's my first time in Ohio. I think it's my first time in the Midwest because somebody told me Chicago is not the Midwest. I don't know. So I've been into Chicago a couple of times, but when I use that as Midwest, they're like, it's not really Midwest. So first time in the actual Midwest, I guess. I'm super happy to be here to talk to you all about everything and anything generative AI. But I'm not the only one. There's a lot of sessions today, and it's not all gonna be about generative AI. Remember, there's serverless, there's Git, there's DevOps, there's S3 storage. So if you want to go and check out all of these sessions, they're on a piece of paper or on a website. You can go check it out. I want to point out a couple of them. So at 10 a.m., there's my good friend and colleague Banjo's workshop. So if you want to build stuff with PyRock, with Q and Bedrock, if you want some hands-on stuff, Banjo is your person. There's a panel which I'm going to be part of if you want to listen to some people discuss generative AI. It's going to happen at 11:30. There's a session by Chris at 11:30 about getting started with serverless website analytics. Later on, Brian Tarbuck is going to do some S3 fun stuff, so definitely go check out Brian. Julia is here. Yeah.
I'm not going to talk about Gen AI in my talk.
Why? Come on. Jesus, be with the times, Brian. So Julia is going to talk about Kubernetes and containers, which is always great. And Trevor is going to show you how to build an actual chatbot. So, without further ado, a disclaimer. Generative AI is way bigger than what I'm about to talk about. I don't know all the answers, neither do you. Neither does generative AI. So, I'm gonna take you through where we are right now, what's happening, how can you benefit from generative AI, and where are we gonna go in the future. So, what happened over the last 40 years? Mainframes, right? That's taking us back. I know one man who knows mainframes here. Yes, you, Brian. Mainframes, the first technology wave when we all started using big old computers to do fun, interesting stuff. Then we switched to personal computers, little things that can sit on our desktops. And we decided to build servers, bigger versions of desktop PCs. And I am struggling with connectivity here, so please ignore the flashing lights. We moved from servers to virtual machines, then to containers. Then all of a sudden, the cloud showed up. No longer is this thing running under your desk, in your data center, or wherever. It is running somewhere magical in the cloud. We switched from basically the on-premises technology delivery model to the cloud. That's cool, and we all adopted it, kind of. Not all, most of us. But now, we move to something serverless when we move to the cloud. All of a sudden, you can just run arbitrary pieces of code in the cloud. That's amazing. That's cool, right? That was a big change for me, at least. But now, we're here. All of a sudden, everybody's talking about generative AI. We've been talking about containers. We've been talking about virtual machines. We've been talking about serverless. We've been talking about the cloud. And now we're talking about generative AI. So, is this the third wave? I guess so, right? Things are changing now for you as builders, as engineers, as people in technology are changing whether you like it or not. The same thing happened with the cloud. So, before I start, let me give you my first couple of aha moments with generative AI. When did I decide, oh, this is neat. Here's a screenshot of some code. Not sure how much you can read it, but at the top, there's a big old comment that says, load the inventory of computers from the JSON file into individual computer objects and store them in a list. Make sure to check yada, 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 yada. I wrote that piece of comment, and it gave me that code. I'm not good in Python. I don't think Python is a good language. Fight me. But it did that for me. Like, I could have probably written that after a couple of hours digging through documentation and trying stuff out, but it did that for me. Is it the best piece of code? I don't know, maybe, probably not, but it's good enough. I was like, oh, this is amazing. And I gave it such detailed instructions, it did all of the things I wanted it to do. Okay, that's neat. Second, the same thing, but this time I went even further. I wanted to use knowledge that's not just Python. I told it that store the computer in a DynamoDB database. If the table doesn't exist, give the user the AWS CLI command to create the DynamoDB table. So not only did it generate me Python code, but it also gave me the CLI command to create a table if it doesn't exist. Neat. There's a bunch of different information here that it gave it to me. This thing went me go like, oh, can I be a developer now? Can I code for money? Is this a thing? Yes. Okay, before we move on, who am I and why should you care? Who is this bald man yelling at you? My name is Darko. I am a computer person. I am originally from Serbia. I live, work, and breathe in Seattle. I do not code for money. I've never written a piece of code that earned me money. I am what they used to call a system administrator a long time ago. Do you remember that? Screwdriver, racking and stacking, yeah. So I used to do that. I don't build code, at least I didn't, but I do appreciate code. I am an appreciator of technology, how things are built, how things work, and how things operate at scale. I have around 20-ish years of experience with this. Straight out of high school, I just went to do computers, and that's how I'm here. I am quite the historian. When I say quite the historian, I mean I appreciate computer history. I have a huge collection of old computers at home, so if you use an old computer, I probably have it in my garage. So I understand the history, where we come from, and where we should potentially go in the future. I also happen to work for AWS as a developer advocate. Okay. So how does Gen AI work in simple terms, right? This is one of the things I want to explain here for all of you to understand that generative AI is not magical. It is kind of stupid, but in a good way. So how does it work? You enter a prompt, a piece of text, A, B, C, D. You submit this thing to generative AI. What happens next? What do you think what happens next? Does it magically go and figure out what the answer should be? Does it have a database of potential answers to this? No. It kind of guesses what the next thing should come. It literally starts printing out what it thinks should come after the next token. And token is a word or not a word, it's less than a word, more than a word, depends. But it literally just starts producing what the thing should come next. It generates text based on what it expects to be. So when you see your generative AI model print out like the typewriter thing when it starts to like print out words, that's not for show. That's how it works. It literally starts producing tokens one after another, and it gives something out of it. Now, thanks to the plethora of information it has, thanks to the big, huge model that exists, it has a lot of information. It has a lot of things that it can predict that should go next. That's why you keep getting potentially good answers. So, simply put, this is how it works. Not magical, no science fiction, but it is insanely useful. Why is it useful? Why is generative AI the logical next step? Why are we here? Why is generative AI the thing we're talking about right now? This. We kept talking for the last, I think, 10 years. Everybody called data the next gold, the next oil. It's the most important thing in the world, data. We have so much data now. And it's impossible for you as people, as engineers, as humans, as builders, to get all that data. So if you want to build something, you either need to go figure out how to do that, something new, right? I'm going to step back for a second to the olden days. If you needed to learn how to write assembly for the Commodore 64, there was a 100-page book. That's it. All the knowledge you need to write assembly for Commodore 64. How big the book needs to be for AWS, or GCP, or Azure, or whatever. So all of this knowledge, you can either just, well, how can you use it? How can you use this knowledge to build something? I mean, you can Google it, right? Or memorize it. Yeah, right? That's not gonna work, right? We've passed the times of memorizing every framework, every language, every function. It's no longer a thing. You can search it, right? But you know what happens with searching? You keep running into the same questions, same answers, same collection of things that don't really solve your problem. And because the way search engines work is they usually give you not always the most relevant information you need, but close to the relevant information you need, which may or may not be correct. So you spend a lot of time searching for text or code or whatnot or solutions, which may or may not be correct. So, you know, it's just, I don't want to call it a distractor. I think search engines change the way we build code from going from a book to the whole internet. But now, with generative AI, we switched it even further. You use something called an LLM. An LLM stands for large language model, which ingests all the data, all the knowledge in the world, and I'm paraphrasing here, but a lot of knowledge. And then what happens there? You, through natural language conversation, through discussions, through literal human interaction, there we go. Through human interaction, through, like you're talking to somebody, you get the answer. And what has changed here for me is that now when I go and Google something, I ask Google a question. How do I do this in da-da-da-da-da? You usually didn't do that, but now with LLMs, I've changed my approach where I ask a question like I would ask a human, because that's how you get the best answer. So we talked about all of these, collect all of the information we have, all of the data, all of the knowledge in the world, and the only way you can purely digest it right now in the best way is by using LLMs. So they are here because it makes sense. If anything, it's going to be easier to find information. Okay. But Darko, we thought you were going to talk tech. I'm getting into that. I'm going to talk technology, applications, code, and I'm even going to show you something. So where does generative AI fit in your stack? Now, I understand not all of you are developers, not all of you are builders, some of you are not technical, and that's okay. But this is going to show you where generative AI can fit into your technology stack, wherever that may be. Here we have some code, we have a developer, and we have a user of code. The developer writes the code, right? Then the user, don't fail on me. Code is a bunch of functions, just a bunch of functions that return some data. The user makes a query, a SQL query, a query language, whatever kind of query they use to get the right information. 95% of applications are either creating, updating, reading, or deleting data. That's literally 95% of applications in the world. So this is how most applications work. Now, whether your user is going to do it through a query language or through a search field or something like that, but that's what they do. So how does LLM fit into this? How about, instead of a user writing a whole query, they will write it in a human, natural language, right? Instead of select star from users, blah, they will say, give me all the users who are older than 100 days. Thanks to the reasoning behind an LLM, it's able to convert such human questions into an actual query that's going to get you this information. That's one part of it, right? That's easy. That makes sense. What about next? Well, the builder, the developer, the engineer writes code thanks to an LLM, right? Like you saw on my aha moment, instead of them having to write every function, every bit of code themselves, why not ask a model in plain English or Serbian or Spanish or French, write me an application or a function that does X, Y, and Z. Frees up time specifically for the stupid stuff you don't want to write. And then finally, generative AI in the runtime. What? Yes, within the runtime, you can have generative AI. So as your application is executing, you can have generative AI or generative AI functions within your code to do something even better. What? Generative AI at runtime? Let me give you an example of something I've built. Unfortunately, I don't have the code here with me to show off, so I did the next best thing, and it's screenshots. So I have an application that uses generative AI to chat with it. And I wanted my application to be able to help me with my code. So I want to point my application to a source directory, say, let's talk about this code. To be able to do that, I need to pack all of the code in my source directory and send it to the model. How do I know which code to send? Which files from your JavaScript application should I send? Should I send node modules? No, right? So what I did in my application, instead of having a whole database of which extension goes to which project, I have an LLM that I send a directory structure, just the first layer of my directory. I send it to an LLM and tell it, return me a vector or an array of extensions that belong to this project type. So what happens? I send that thing on the right, so the whole directory structure. I send it to an LLM, and it returns me a vector, an array of extensions I should be sending. Based off of that array, I go ahead and pass on all the files I need. I didn't have to write a database with all of the existing languages or project types to send something. I use the power of an LLM to help me do that. I will point something out. An LLM is not a database. It will not always give you the same result. So please be cautious of that. Sometimes it may give you slightly a different set of files. So you have to understand that it's a non-deterministic output. So just so you know, it's not going to be always the exact same thing. So think about the use cases where it makes sense and where it can make the least amount of mistakes. But this was an example of me using this inside of an application. Let me actually do a demo now. Now, actually, I have a slide for the demo. So I'm going to give you a demo of an application I've built that is not a chatbot. Wait a second, I have to do this. There we go. Escape. Boom, there you go. I'm going to show you an application that is not a chatbot. It is not your typical answer me a question. I built it using Amazon Bedrock and Rust as the language. The application is a chatbot, but I've added one feature to it, and I found it insanely useful. I write a bunch of blog posts often, and when I write blog posts, I embed images in them. And one of the important parts of an image in a blog post is accessibility. So I made sure to give each image a caption. Now, I'm lazy. I know most of you are as well. I don't want to look at each image and write a caption. So I built an application that does it for me. So thanks to Bedrock, what I can do right now is point my application to a directory of images. I have a bunch of images here. If I point it here, hit enter, it takes each of this image, passes it on to an LLM. So it just drops it to an LLM, to Bedrock, to, in this case, it's Claude 3. And what the LLM does, it returns back description of each image. So if I do this, captions, you will see that it's a JSON object that says, this image is a close-up view of a front grille of a Toyota Tundra pickup truck, covered in blah, 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 blah. You see, it does all of these things for me. Now, I'm sure there's a service out there, Amazon Recognition, that kind of does things, but this gives me a bit more flexibility in the model choice and the way I handle the stuff. Great. This has been a very useful tool for me because it just does the thing I do. It's not your chatbot and whatnot. It's just a single task, powered by generative AI, just works. I love it. I built this tool in Rust. I don't know Rust. I know a bit of Rust. But I built it using Bedrock with Bedrock. So I basically used LLMs to help me write good code. So I learned as I went on. When I would run into an issue, I didn't know how to write code, I would ask LLMs how to write code. So this application that I wrote called Bedrust, it's a stupid pun, of Bedrock and Rust, I wrote myself live on Twitch. So if you want to see it, there's evidence of me writing this application. But I did it all thanks to a large language model. So I wouldn't be able to do this if there was no large language models to help me do it. They didn't write the whole application for me, by no means, but they helped me get through it. Awesome. And now let's get to the thing where we talk about AI assistants. This is a hot topic, right? the thing that helps you write code, the things that help you build, your purpose-built chatbots to do stuff for you. So I'm going to cover a couple of topics here. Where are these assistants going, right? What's happening? Where are we right now? What can we expect in the future to happen? So this is, when I showed you my aha moment, this is what happened. Inline coding, right? If you've heard about AWS Code Whisperer, now called Amazon Q, or GitHub Copilot, this is what they do, right? You start writing code, or you write a comment, and it populates the rest of the code for you. Really neat, really cool, can be finicky at times, but this is how we started. And this is a really great next step, specifically when you want to do silly things like create a function that uploads a file to S3, or just do some of those like really tedious things in code. We moved on from that to chat, where you have a chat assistant inside of your IDE, inside of this wonderful cozy text editor, be that VS Code or IntelliJ or whatever, via Visual Studio, where you can ask it questions, right? So I'm trying to read a file or read something from DynamoDB. How do I do that? And it gives you the code, it gives you the explanation of the code, and moreover, you can even ask it, what does this code do? How is this thing? So you have this immediate interaction with an LLM about your specific code, right? That's cool, that's next step. But we moved on from that as well. So there's this new thing coming out from both Q and Copilot and whatnot. Agents. Agents are trying to do a lot more than your just like coding buddy. Agents are trying to be your junior developer giving you some advice, if that makes sense. So what happens here with an agent, you can ask it a legit task. Write me a CDK template that generates a Lambda function, an EC2 instance, a VPC, or whatnot. And instead of it giving you some random inline code, it actually generates all the code for you. It is not perfect. Don't expect this to replace you as a developer. It is okay. It has its problems, but that's okay. That's how it works, right? You give it a prompt, it gets you a plan. Here's what I'm gonna do. By the way, this is all Amazon Q inside of VS Code. And ultimately, it produces a diff. It produces some code that's gonna do stuff for you. Actually, I think I can show this to you. I wanna preface something here. Demoing generative AI is hard. I haven't recorded this. I'm gonna do this right now. It may or may not work, just so you know. And that's kind of how it works. It was so easy demoing tech before generative AI, because you at least knew it's gonna do what you need to do. So I'm gonna do a thing now. So I have VS Code here, and I'm gonna open up a directory that is called, let's see, I think it's TMP, like that, Columbus. Give me some CDK, yes, nice. This is my CDK directory. I have an empty, just now created project in CDK. There's nothing in it, it's literally an empty CDK stack. Perfect. What I'm gonna do here is I'm gonna ask Amazon Q to do something. So I'm gonna use the agent here. I'm gonna do /dev, and I'm gonna describe what I want it to do. And I'm gonna use the thing I already copy pasted here. So let me find the thing. I have a thing so I don't have to do it myself. So I tell it, create me a AWS CDK stack that has a VPC, an EC2 instance running Amazon Linux 2, a DynamoDB table, and a Lambda function written in Python that returns the current time when it's executed. Simple, not complicated, but it will take you a while. It will take you like an hour to build this, right? When I hit this, it says, okay, let me create a plan. It may take a few minutes. Now, this is not immediate. It literally does take a few minutes. So what it does in the back end, it takes your requirements, it generates you this wonderful little multi-step plan, what it's gonna do. And if you're okay with the plan, you tell it to generate the code. It is a fascinating thing. It is amazing. I'm in love with this to an extent. Again, don't expect this to be a miracle. It's not gonna create everything and anything for you. But I have a whole discussion about that in a little bit. So while this is happening, I'm gonna go back to my PowerPoint, and I'm gonna talk to you about one of the other elements of agents, or what are we progressing with agents, right? So cool, code generation. But here's another thing. We went from English, or your language of choice, into code. But what about code into English? Has anybody here written a changelog? Hands up, changelog. Anybody written here a README file? Yeah, there you go. So what if you can take your code and the changes you made and make it into a README file or a changelog? That's cool. So that's actually what you can do here. You can use agents to take all of the changes that you've made in your application and update your README file, update your changelog. So it knows the exact changes made inside of your code since last commits, and it's able to do that. Again, saves you sometimes. It's not the most important use of your time is to write a changelog, but it does help if you can have somebody else do it. So as you can see here, it creates all of these things. Look. Basically, it can also document stuff in it. It's just beautiful. Again, it helps you do all of the tedious tasks you don't want to do. That's the whole point. There's a whole. I'm going to share the links, by the way, later on from my colleague Massimo. He wrote a bunch of stuff here how you can use Q to produce documentation. I'm going to be sharing these links in a bit. In the meantime, let's see what's happening here. Okay, so. I'm gonna stop this for a second. There we go. And let's see what Q has done, because Q has generated some code. Actually has generated a plan. So here's what it does. Okay. So here's the steps needed to accomplish the given task. Import a bunch of stuff. Well, there's a file. Import a bunch of libraries for CDK. Define a VPC resource, define an EC2 resource, define a DynamoDB table, create a Lambda function, create a Lambda function code, and then define the Lambda function resource within a thing. It also creates tests because it loves creating tests. I'm going to tell it, please ignore the tests, as we all do. So it's going to now say, okay, no tests. It's going to regenerate the plan, and then once we're fine with it, it's going to do the code. We're going to come back to this in a bit, as I want to move on with the discussions. We don't want to stare at generating an answer here. By the way, my suggestion to the service team is, while it's doing this, it should just drop a bunch of fun facts for you while you wait. Like, did you know the most used language on Lambda is JavaScript? But we're not going to wait for this. We're going to go back into PowerPoint because it's fun. Okay, code to English. All right, so main question. When is my... There. The main question. Can you trust generative AI? Can you trust agents? Can you go ahead and just blindly run code on it, right? Is that a thing? How do you feel about it? Think about it. How do you feel about letting a generative AI write your own code? Well, we go back to we were here once, a long time ago. Inside of 2024, right? How can I trust a generative AI assistant? How can you make sure it's not hallucinating? You need to verify each answer and every artifact, right? Okay, roll back 23 years. How can you trust a virtual machine? How can you make sure that the bug is not in the hypervisor? How would you need to reproduce your bug on a physical server? This happened before. VMs, clouds, containers, function. Every time a big shift happens in technology, we're always like, I don't know. I like it the way I used to work with it, right? I liked that this was the way it worked. It was fine. I don't want to have to think about it. It's great. But this is the thing that happens, right? You have to put a bit of trust in it, right? Not too much. Like for everything else, you have to put a bit of risk into what you're doing to actually get this benefit out. If you're just hoping it's going to be perfect every time, you probably don't work in tech. So do you trust everything and everyone? That's a big question, right? Can you trust your consultants? Can you trust SAs? Can you trust technical account managers? Can you trust this guy? Probably not. Can you trust a pipeline, a test? Can you trust, everything? Ultimately, it's all about controls and risk mitigation. You need to be able to absorb a certain amount of risk, a little bit of a risk when you build stuff, so you can get some value being returned. And that value in this case is time, is effort, is having you as a developer, as an engineer, go home early. Don't worry about writing silly, arbitrary arrays or functions and structs that you don't really have a lot of effort in. You also have to think about what are the controls. Like if your large language model gives you bad code, what's going to happen? Can you control it? Can you prevent it from causing issues? Of course you can. There are things in place you can make that it doesn't really break the stuff you're doing. But again, with those things in place, you should prevent failures, right? Because remember, every Amazonian quotes this. Every Amazonian I know had this slide. Everything fails all the time. I love this quote. It's just such a get out of jail free card, right? Everything fails all the time, right? So if you think about your infrastructure failing, you put controls in it. You understand the risks. But why generative AI shouldn't fail all the time, right? It also fails. So you need to be able to understand that Gen AI is gonna fail. It's gonna not give you the right result, and that's okay. You have to be able to take that risk if you find value in what you get at the other side. Speaking of value, let me see. Okay, so it gave me I'm gonna run this again because it's gonna generate my code. Give me a second. So it gave me a good plan right now, but it's gonna take a couple of seconds for it to generate code, and we're gonna see if it works. It may not work. It's all about the right mindset, right? So here's the problem, right? So something I hear about generative AI from myself, my colleagues, and you, esteemed users of AWS, is, well, this is not entirely correct, right? The code it gave me has bugs. But yeah, I mean that's how it works. I think we as a technical society have expected everything from generative AI, and at least to our credit, some people present it to us like that, like this is solving everything, right? It's not. So it's not entirely correct, and that's okay, right? But how about thinking about a different way? Did it help me Did it help me save time, right? Like even if it didn't do everything correctly, did it do so much things well? So it saved me an hour, half an hour, 45 minutes, right? If it did, perfect. I have an extra hour in my day to do something else. So this is an important thing, right? Even though it's not gonna do the most perfect job yet, it's still gonna be able to save your time. So just open up your mind a little bit when it comes to these things. Still generating code. Okay, not saving me time. So, and the last question, are they gonna replace us? Well, that goes back to, look, can you trust them, right? No, of course, right? It's not a thing that's gonna go ahead and just take my job away. The fact that I didn't spend 10 minutes writing some Python code does not mean my job is gonna go away. I'm gonna invest that time and effort into something else. Thanks to generative AI, I was able to learn Rust. I couldn't do that before, right? So these things are not gonna be here to replace you, to kind of make your job obsolete. They're gonna make you, as engineers, as builders, do a better job. All of you, whoever has written code or built things in the cloud on premises, have come to a moment where you hit a brick wall. It's like, I don't know what to do next. I have this thing I have to accomplish, but I don't know how to move on from this point. What happens then? You Google, you open up a book, you get distracted, you start looking at YouTube. You spend many times on social media yelling at me, how does this not work on AWS? Why is it broken? All that fun stuff. And that gets you away from your job. It gets you away from your task that needs to be executed. So what I use generative AI for mostly, I build things as I do, but when I hit a brick wall, that's it. I just go ask an LLM to help me move away from there. As soon as it unplugs me, I just keep on doing the rest. That is the thing. It's this massive blockage remover. Like, it's the great blockage remover of our times. Okay, let's look at code. Yes, thank you. So it gave me a couple things here. There's a lib file and a bin file and a lambda function, right? So if I click at this, as you can see, it did a bunch of changes. It removed this comment, which we don't need. It imported a VPC, an instance type, a machine image, a table, a function, runtime code, all of these things. It even changed, for some reason, the stack name, but that's okay. My resources stack. It creates a VPC, creates an instance, creates a DynamoDB table, creates a lambda function. And if we look at the lambda function here, somewhere, there we go. Here's the lambda function. It literally just does return the current date and time. That's it, right? Super simple, nothing too complicated. And I'm gonna, because you're all so nice, I'm gonna try to run this. This may fail. CDK deploy. I have no idea if this is gonna work. It may not work. It works. look at that, okay. It's deploying something, maybe. We'll see later on. But the code works at least. It is compiled into JavaScript, so it's going to do all of these things, and we'll see at the end of the day, does this actually work? Okay. Back to this. Ultimately, we want the role of generative AI assistants not to be to generate written text, not to generate images. And I know we do that a lot. I'll be honest, I hate it when people use generated images online because it's so obvious that it's generated. When somebody posts a comment on your post on LinkedIn or Twitter, and you obviously see that they used an LLM to generate that comment. We know it, right? And that's not what we wanted to do. We want LLMs to do our dishes, do our laundry, fix our code, build our stuff, so we can spend some time actually doing creative stuff and stuff we truly, truly enjoy. And we're not there yet, right? We're not there yet, but we're slowly moving this. Also want to talk about one more thing related to my demo. You saw me ask it to generate some CDK. But you may say, Darko, I already know CDK. Well, that's great, right? And because you know CDK, you can make it better. But we've done this already in the past. The same argument was made a long time ago. So, and I don't know how long this was ago, but like, let's say 35 years ago, we had assembly. Right? You write Commodore 64 assembly, x86 assembly, MIPS assembly, whatever. It was the bare bone access to the CPU. You could do everything and anything. Then some cool kids invented C, right? We're gonna do C. No longer do we need to write CPU instructions. And people complain, well, I don't have full control. Okay. But then we moved on from C to Python. Then some new cool kid said, well, now I can control my memory allocations. Right. And that's it. We keep moving up the stack of abstractions because it makes it easier for us to do stuff. The same is now happening with infrastructure as code, right? Does anybody not know what infrastructure as code is? You all know. It's deploying infrastructure to the cloud using text, right? CloudFormation, Terraform, CDK. Well, we had this progress as well. We had CloudFormation, right? It's the assembly of AWS. Then we moved to CDK, which is really, really better, right? And now we moved on to me telling it what to do in a little prompt, and hopefully it gives me what I need. So we move up this stack, and again, this is aspirationally it's going to do it. It's not going to be 100%, but it is this thing what it's doing for us that makes our lives that little bit easier. Just gonna go back to this. Look at this. It has deployed. But you don't see it. Ooh, 1 second. It worked. Yesterday when I was preparing this demo, I'm like, I don't know if this is gonna work, but we'll see. But it worked. It deployed it successfully, so it gave me decent code. Now, the more complex stuff you ask it to do, the lesser is the likelihood it's gonna do it correctly. But I have a slide about that right now. So. Move on from this. So here's something my friend and colleague Massimo has come up with. I cannot take the credit for this. He did it. And he has a wonderful blog post on this same exact thing. It looks complicated, but I'll explain. Here's a tentative framework for you as developers, as builders, to adopt generative AI today, the 13th of June, 2024. When you do something, there's different levels you can find yourself on this axis, right? When it comes to your level of knowledge, be that low level of knowledge or high level of knowledge, the same goes with the complexity of the task. Either it's low task complexity or high task complexity. Let's say you are there at your level of knowledge, whatever that may be. Programming language, CDK, building the cloud. The more you move from this position in both your knowledge and the task complexity, you are losing or giving control, right? Because you know more, right? You have more knowledge. If you go left on the complexity task, you have more control because you know all that stuff. As soon as you start moving away from that axis to a higher task complexity, you are losing control. And here's how you're losing it. Because you're losing it using generative AI, right? So if you're asking generative AI to give you something that you already know, right? Simple task. Generate me an array with all of the colors of the Windows 16 color palette. It's nothing complicated. You can write it down probably in 15 minutes. You have to Google it a bit, do some formatting, and you do it. But it gives you a little boost. You don't have to do it yourself. It's going to do it for you, right? You didn't have to spend a lot of money. You didn't lose a lot of control. It did a simple task for you without having to worry about it. If you go the other side of the thing, well, this is the learning zone. This is where you ask it something that's beyond your knowledge. Implement a function that uploads a file to Amazon S3 and it uses a progress bar. I don't know, right? I don't know how that works. So it's on the edge of your knowledge, so you know it, but it helps you learn something. So instead of boosting you and moving you fast, you actually use this tool to learn stuff, right? You build this, but you also learn. That's how I learned Rust. That's how I learned to build tools, because I always kept pushing it to the edge of my knowledge, but not too far. If you move it too far, to the danger zone, if you ask it to build everything and everything, you lose control. You lose control. And there's a less likelihood that it's gonna give you the exact thing you want. So if you go too far away to the danger zone, you don't really get a lot of things out of it, because you get this code which maybe works, you have no idea what it does, and you're just hoping it does the thing you need it to do. On the flip side, if you ask it to do super simple things, create me 5 variables that describe the user, that's you're just wasting time and effort and money on having generative AI do something that's so trivial that you gain nothing from it. So the goal is, for your adoption, is to be somewhere in this wonderful green circle, right? So I know it's complicated. There's a whole link. I will share a link later on. Massimo explained this in a blog post much more eloquently than I did. So this link is going to be available to you all later on. Lastly, I want to show you one more demo kind of related to this whole thing. I think I still have time. I'm going to give you a demo of the boost zone, where I found myself the most useful. So here is a little application I wrote in Rust. It's an application that, let me see if I can do this. If I can do just cargo run. This application prints, oops, you don't see anything. That's just great. This application prints, I think, 14 or 16 bars on the screen. It's currently only black and white. That's not colorful. I have this application called Happy Spectrum. How can I add colors to this thing, right? So my code doesn't matter here. My code just draws a bunch of stuff and it takes colors from a color bar, from an array of colors that currently only has black and white. What I can do here is I can tell it here, let me see, Amazon Q. I can say, let me see if I have the prompt saved somewhere. Yeah, okay, there it is. So I will tell it, give me a Rust vector that contains all the Win16 colors. Win16 is a palette of colors for Windows 95. And the colors should be presented in hex like this, and they need to be encased in RGB U32 blah, right? If I do this, it's gonna generate me this. It's gonna give me, hopefully, let's see. It worked last time, so there you go. So it gives me this whole vector here that I can just use. So if I just copy this whole thing, actually I'm gonna do this. I'm gonna copy the whole code, come back here, paste it in, delete a bunch of boilerplate code I don't need, and delete this. So it was aware of what framework I'm using. It knows that I'm using Nano as the framework for graphics. Save, and fingers crossed, cargo run. There we go, colors. So it's a stupid task. I could have probably Googled it, I could have looked for it, but I don't want to spend 15 minutes writing this array of colors, right? It knows what I need to do. It's one of those boost zones. I just told it to do that and it did it for me. If you need something to mock something, like you need an array of 100 different file names, it can generate it for you, right? Some of those things that don't really give you a lot of benefit, but save you time. Awesome. I'm almost done, my friends. We are done with the learning. Move through all of these things. That was my demo. Conclusions. For all of you out there who are now using generative AI or not using generative AI or are maybe gonna use generative AI, keep an open mind, right? It's not the silver bullet. It's not the solution to all of your problems. Try it and expect it to fail. right? Because proving things wrong is extremely easy, right? It's super easy to say, well, see, the way that Python code did, it's just bad, right? Or your vector should have been better labeled, yada, 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 right? It's always easy to say something is wrong. But extracting value from whatever it does can be useful. Remember, you're trying to pinch out value from things you do. Save 15 minutes, save an hour of your time, and don't do anything, right? It's kind of a thing. Lazy can be a good thing. Let these tools help you be lazy in an ethical way. I'm not saying you're not to do your job, but maybe you can just not spend an hour writing a bunch of arrays. So, the question you should ask yourselves always when it comes to these tools, where do you want to go today or tomorrow or in the future? What do you want it to do for you? And think about it that way. Think about what you can use these tools to help you build. You can build tools with them or use somebody else's tools out there as well. If you're interested in more cool stuff about generative AI, that's a link. You can take a picture of this right now, or you can ask me later on. community.aws/generative-AI. It's a collection of articles by Amazonians and non-Amazonians about generative AI. There's a bunch of really cool stuff there if you want to learn from other people's experiences. Lastly, thank you. Thank you so much. Feel free to connect with me on LinkedIn, ask me questions, whatever. I'm open to discussions. Do we have some more time for me to ask?
We do. We've got probably, say, 7-8 minutes.
Okay, cool.
Want to do some questions?
Yes, questions, please.
Awesome.
Any questions?
All right, raise your hand. Also, is that framework not the coolest thing? I love that.
Which framework? The framework.
With the learning zones. Very cool. Fellow Clevelander, yes.
So I was curious, your Bedrust application that I think it sends images and then it provides a summary back. How much of your time do you think it would have taken to build that versus how long did it take you using, and how much did the LLM save you in development time?
I would probably not be able to build it myself that much. So I'm not a Rust developer. Like I've started learning Rust in March this year. And I've learned it by building open source projects with an LLM. So it has saved me immense amount of time on these things because again, I don't code for money. I know how to write scripts and all that fun stuff, but none of this. So if I want to put a number on it, it saved me months of me just being able to do stuff. So definitely. And it was good enough for me because it's not just giving me code. It's explaining to me what is happening. Thank you for your question. Brian, and there's one more here.
Do we really give Tarbox the mic? I don't know if this is a good idea. It's probably bad. I'm not doing it. No.
So Darko,
yes.
Always great to hear from you. But I'm wondering if you could talk a little bit about bias in the world of Gen AI, because it's in AWS it's okay. The answer is what it is. But we see that so much of LLMs are trained on US and the cultural specificity and the bad data, and just riff on that a bit, man.
So one of the things you have to keep in mind when it comes to using LLMs is that a huge population of the internet, of the population of the world does not have as much data on the internet, right? So if I start asking it something in Serbian, I will get way worse responses or not Serbian specific responses, right? You can probably ask an LLM how to file your taxes in the United States, but not in Serbia. So please do keep that in mind. When you're building something, it has a very specific, it's trying to be as neutral as possible, but thanks to the overwhelming information it gets from the United States, it's gonna be skewed towards the United States. Like I asked the people coming in, what's the best food in Ohio? And it probably knows that, but if I would ask it what's the best food in Chisinau, Moldova, probably it wouldn't know how to tell me that.
What is the best food?
In Moldova? I don't know. I've never been to Moldova, unfortunately. But I would imagine it's great.
Thank you for the talk. The metaphor that I've heard is that you treat generative AI like a junior developer on a lot of Red Bull at 2 a.m. So, which is, it puts out code, but yeah. So what would you do to kind of control that? Because the thing that I've kind of heard would be either peer review it like you would a person, or maybe even like try to do a test-driven development and make sure it validates tests. Like what would you do to reduce some of the uncertainty around it working while also keeping the values? Or any like a couple things that you would implement?
Yes. So one thing I want to point out here, if you're not a developer, if you've never written code, LLMs will not help you write code, right? If you don't know what a function is, if you don't know what a variable is, it's going to be a hard thing for you to write good code. So being able to detect issues immediately, oh, that's bad code, is the first thing you should look into. Second, yes, ask it to write tests as much as it can. But before any of that, all of you make sure not to be lazy when it comes to prompts. Prompts or prompt engineering is a whole science or an art, how to properly ask a question. So be as precise as you can. Don't use negatives in your prompt. That's a weird thing that I learned. Never use a negative in a prompt, right? If you're asking it to do something, ask it to do something, not to not do something. Right? It tends to freak out when you tell it not to do something. So make sure to ask it what you exactly need, as precise as you can. Even telling it so much, please give me the response inside of these XML tags or whatnot. So be as precise as you can with your prompts, and that's gonna help you go a long way there. But tests, pipelines, any way you test your code should be the way thing. The thing that would happen here is you need to shift left. Do more testing locally than having to deploy every piece of code to a pipeline. So that would be my big advice here.
So, quick question, and I'm not sure if you're going to be able to expand on how AWS with Code Whisperer is addressing this, but one of the things that's already happened is GitHub's done a study based on Copilot for the last year. And one of the things that they've noticed is the amount of redundant code that has been added into repositories since the introduction of LLM coding assistants has arithmetically increased. It's like an arithmetic increase in redundant code as opposed to, as a developer, it's you write it once, okay, you write it twice, meh, you write it 3 times, you build a library and share it. So what's the approach for the amount of code redundancy and all of the ramifications for that that AWS or Amazon's looking at with Code Whisperer?
So the redundancy problem here is kind of a global thing right now because everybody, including myself, all of a sudden started coding, right? And we just decided to build our own things because now we can. What I see happening here is as these models become more, because these models are not real time, right? When you ask an LLM something, there's usually a couple of months delay, right? As these models become more real time, the more they will take into account existing libraries, existing frameworks for them to work. For example, if I go and ask Claude 3 right now, what is Amazon Bedrock? It doesn't know always what Bedrock is because it's too new sometimes, right? So what I see happening here in the future is that these models are going to be much more cognizant of what exists out there. So instead of you writing your own library, it's going to give you an access, here's what you should use and how you should use it. So I don't know if that's going to be the case, but that's somehow how I perceive this being in the future.
All right, we're going to wrap up here. A couple of quick housekeeping things. If you are doing Banjo's workshop, that is on the 3rd floor, correct? Okay. Everything else is going to be down here. Nathan is making weird symbols at me. I don't understand. Okay. So give him 2 minutes, right? Okay, sounds good. Did you?
Just one more thing. I'm going to be here all day, so if you have any questions or you want to see more demos or if you want to look at some code with me, please do approach me. Please do tell me. I'm more than happy to talk to you. So.
And Darko, you've got 11 o'clock?
Yes, I'm going to have the panel here with people, so yeah. If you want to check out Bedrust, it's on GitHub, so I have a whole 38 stars. Yeah. Awesome. Thank you, friends. Thank you so much.